Alright guys, welcome to your 22nd video, and in this video I want to talk to you guys about collisions. Specifically, how the conservation of momentum will predict what's going to happen after two objects collide into each other. So, in physics, people love talking about collisions, and probably if you talk to a high school student and he says that he wants to go to school for physics and you say, okay, what are you going to do once you graduate? He's like, oh, I'm going to watch cars crash into each other. I don't know, something about them. They love watching things crash into each other. Kind of weird, freaks me out. But anyways, before we get started with my example, let me go ahead and define momentum because I want to pound this in your brain one more time. Momentum is defined as mass times velocity. You got it? I told you guys enough where you probably remember it right now. So now here is the example. Say you have two balls. Ha ha ha, two balls. Laugh it up, guys. Ball A and ball B. Now, both balls have the same mass. They're pretty much identical, except for ball A is moving through the air. Maybe you hit it with a tennis racket or something. I don't know. So, I guess it will probably be better to make a little chart before and after the event. Now, the event is, of course, whenever ball A smacks into ball B. Now, let me go ahead and might as well finish this chart if I got this far already. Now, before the event, as ball A is traveling through the air, it has a momentum of, let's just say, 20, and the units would be something like kilograms times meter per second, but we'll just say it has a momentum of 20 right now. Now, ball B has a momentum of 0. How do we know that? Well, ball B isn't moving at all. It's still in one place right now. Now, of course, like I said in the last video, whenever an object has a velocity of 0, it doesn't matter what the mass is because whatever you times by 0, the momentum must be 0 as well. So, ball A has momentum of 20 before the crash, and ball B has a momentum of 0. Now, the moment these two balls collide, what's going to happen is ball B is going to go flying because it just got crashed into, and ball A is going to stand still. Now, let me go ahead and, should I explain to you guys, or, okay, I'll explain this first. Whenever you're playing a game of pool, this is exactly what happens. Like whenever you hit the 8 ball. We'll say instead of ball B that this is the 8 ball. When you hit the 8 ball with the cue ball, aka A, the 8 ball starts to move, hopefully it goes into a pocket, and the cue ball stays in the same location, hopefully doesn't go into a pocket. So that's basically what the conservation of momentum is in this instance. As soon as you hit ball B with ball B is going to start moving and therefore have a momentum of 20 kilograms per meter per second, meter over whatever you want to call it, and ball A is going to stay in the same location, not move, because it transferred all of its momentum to ball B, therefore maintaining the law of momentum or conservation of momentum, saying that the total momentum of the system must be the exact same before and after the event. So before this event, ball A had all the momentum, which is 20, and the total system had a momentum of 20, and after, even though that the momentum shifted from ball A, it still had the same amount of momentum. All the momentum was conserved. So I think you guys finally understand the conservation of momentum. If not, it's not my fault because I pounded it in your brain as hard as I could. So in the next tutorial, we're going to continue talking about momentum, but we're going to move to some more advanced examples. So anyways, thank you guys for watching. Thank you guys for watching my videos. By the way, I got a Twitter now. I'll put a link below. And yeah, do I need to plug anything else? My website, maybe, and follow me on Google Plus and send me a donation of like $2,000 if you wanna. Anyways, I'll see you guys in the next video.